Okay, so just click around to 5 o'clock. My name is Richard Cartwright. I'm going to be presenting an open source Internet of Things for IP media workflow. I'm from a company called Streampunk Media. Streampunk Media first appeared at NAB in 2016. We're a brand new startup company. And we're based in Scotland in the UK. Our aim is to democratize professional content production using commodity infrastructure wherever possible. We develop open source software for stream-based media production, and we're trying to support a transition to software dynamic infrastructure. A little bit about myself. I'm CTO and founder of Streampunk Media. I am a computer scientist, and I previously worked at the BBC, at Standard Advanced Media, and I was a technical steering committee chairman at the AMWA, and I'm one of the joint co-authors of the Joint Task Force for Network Media Reference Architecture. So what am I going to be talking about? Well, the story so far is we decided to create a company on an open source business model. In other words, we're going to give our software away for free and sell our expertise, and also try and perhaps move to selling cloud services. We're a startup company. We're deliberately trying to build with no bespoke hardware, and we want to use smart home technologies and Internet of Things ideas to build out professional media infrastructure and apply the expertise that we have from file-based workflow and the internet to real-time streams. We're writing software only, and we're starting from the ground up saying that everything that we do will be cloud fit, will be secure, should be intuitive, not too many IP addresses. Let's try and make everything happen as automatically as possible. Scalable and using IT wherever possible. We want to use professional media standards though, so the right color space, the right number of bits and the bits depth, but in such a way that it's easy for millennials to use. So you should be able to plumb your Amazon Echo into the ecosystem and do that with a few lines of JSON. We also want to demonstrate some of the agility and new workflows that are enabled by the JTN MRA in general. So this is an instance of the JTN MRA, but as a reference architecture, there are other things we can do with it. So let's try and demonstrate some of that. Everything we do sits on a commodity platform, CPU, GPU, virtualizable, runs on PC, Mac, Linux, and also Raspberry Pis. We're playing with Raspberry Pis. We write in Node.js JavaScript with C++ bindings using a tool called NodeRed, which I'll show you. Software on GitHub, Blackmagic cards for ingest and output, Windows Rio to do UDP acceleration, Ansible for software automation, and REST APIs for configuration. And this technology is being trialed as part of an IP proof of concept of the BBC in Northern Ireland, and is also part of the AMWA labs. You can find out more in the Futures Park, just along the hall from here, on the AMWA booth, N1431 FP Futures Park. So, what's this NodeRed thing? Well, it's a tool that you can install on your computer. You install Node.js, long-term support, NodeGype, which allows you to do C++ bindings, and then you install this thing called NodeRed. You run it, you navigate your browser to localhost port 1880, and a web browser. In a web browser, you have a set of capabilities on the left-hand side. You have a flow-based Internet of Things programming example, programming environment in the middle. So this allows you to wire, what NodeRed allows you to do is wire your IP-enabled fridge to Twitter, or your heating controller to your iPhone. It's an environment for doing that kind of thing. You design and program your Internet of Things, and then you hit deploy, and that goes, that runs on the server at the back end. How do you make it media specific? Well, in the top corner, there's a menu button. You select Manage Palette. This is the palette of capabilities that NodeRed has. It brings up a dialog box. You can install on the fly through the web browser a new capability. Type in Dynamos, and when you have the 10 professional media modules that we've added here, you have to install our core module first, and then after that, you can install things like Audio I/O, SDI, and so on. I'll show you some of those on the next slides. So what does it look like in use? Well, so now we have these capabilities on the left-hand side, which are media-specific. In the simplest case, I might want to just play a WAV file, a WAV file. So I would take the WAV file and I'd plumb it to my speaker, I'd hit deploy, and I would hear that WAV file play. What's actually happening there is that grains of media are flowing down this pipe. I could be more complicated. I could take an SDI input, I could put it through an FFmpeg streaming encoder, make an MPEG transport stream, do the same with the audio, keep a copy of what I make in the transport stream as separate files if I want to. So, a more complicated piece of infrastructure that I built there. Or I could take an NMOS style RTP stream, which will work eventually with 2110 or TR03 type stream, mix it with something I've got on a cloud store, put it into a software multi-viewer, and then put that output out on the screen via SDI. So I'm just plumbing together infrastructure, but I'm building it in a web browser using a set of software components. The things that we've implemented to date, we've got FFmpeg as a streaming transcoder, RTP-IO, which is MPEG transport stream, and TR03 style streams. We've also got some HTTP-IO, and I'll describe some of that in a second. We've got some bindings to WebGL to do some transformations, so video mixing and effects on the GPU. We can do audio input, output on the cards inside the computer. SDI input, output, currently Blackmagic, but we're expanding the range of cards that we support. File I/O, so we've got some MXF, some MOV files, some RAW files, some WAV files, so media file formats. And also some fittings, which allow us to do stream-based video editing as well. Now, one of the things we've been very keen to make sure we do in this environment is make sure that it's an efficient use of compute. Everything in this model is flows and grains in an NMOS sense. Everything will register itself with ISO 4. But what I'm demonstrating here is that in the default mode, NodeRed is an event-based model, and it sends the grains down the pipe as fast as possible. But if we do that, and we did that with a loudspeaker, if we sent things as fast as possible into the speaker, then that would be an error. We'd overload the speaker, we'd hear garbage, it wouldn't work. So what we've done is we've added into NodeRed the ability to support back pressure along these pipes. So the speaker asks for the media when it's ready for it, and only receives the grain when it's been requested. So we have back pressure running along our flows. And in that way, we don't block our processors, we don't go to 100% waiting to read a file. We are making efficient use of multi-core processing technology. And this comes from big data. It's a concept called reactive streams. So a lot of data in big data is being streamed. Can we use the same technology here for media? We can work the other way as well. If I've got a file, I can write to files much faster on computers than a microphone can produce the audio data. So I can also delay sending my grain to my WAV file. So I either have back pressure that stops me overloading my speaker, or my microphone just slows down the speed that it sends stuff to the WAV output. I can balance my use of compute. Alternatively, if I've got my media on a cloud store and I'm trying to play it on an SDI output, I might get an error if I can't get the data out of the cloud fast enough. But at least with this technology, I know I've got an error. So I can report that error higher in my infrastructure, up to a workflow engine, for example, and know that something has gone wrong. One of the benefits that we have with using something like NodeRed is that it gives us a playground where we can try out different things. So as well as building out the sort of RTP streaming that we're seeing here, we've also been looking at some of the agility, business agility we get if we move to using HTTP and HTTPS transports as well. And also it gives us an ability to explore what other optimizations there are in the network card if we use a TCP protocol rather than a UDP protocol. Now RTP gives us multicast scaling if we want to use that, but HTTP we can start using things like web caches to do scale. So it's just a different approach, and it's still using a mass technology. RTP, fantastic for low latency, for live sport workflows, and that kind of thing. But where we're not so worried about the low latency, we might be able to get some more business agility by trading some latency and bandwidth. So maybe I can go from local area network to wide area network. I also get the benefit with UDP. It's my responsibility as a software developer, if I'm doing software only, to build the reliability and to make sure my UDP is performant. The TCP, I can benefit from some of the hardware accelerations that Intel have put into their network cards. I can benefit from the security that we can do with HTTPS and the public key infrastructure, and the reliability of TCP. So by trading a bit of latency, I can benefit from some of the features of the underlying hardware and internet platform. So as an example, with RTP and software, I split my video frame up into 220,000 packets, UK 1080p 50. I send each of those packets, reassemble them at the other side, and I get my video frame. And so in that way, I have replicated SDI, and I can replicate my SDI workflows, and I've used my network in a sequential and unidirectional way. With HTTP, a bit more latency, but I put a frame on a server. It is transported somehow using TCP acceleration on the computer in some form of chunks, possibly in parallel, and reassembled at the other end for me by the underlying hardware. So in this way, it's a parallel bidirectional use of a bidirectional network packet system that allows me to perhaps do new things, the security, reliability, and maybe other business agility, things I hadn't thought of. Use the back pressure that I was demonstrating on the previous slide to spread processing across multiple nodes. Now, NodeRed runs on one computer, and that one computer has got storage, CPU, GPU, network. It may also have some ASI or SDI capability as well. What I've shown is that we can add, with NodeRed, on the fly, some software capabilities, and those software capabilities make that computer media specific and what it can do. But I also showed you a design environment, a web GUI design environment which comes out of the box with NodeRed that allows me to use a web browser to design an infrastructure which might be in my facility or it might be in the cloud. But I can also use automation through a REST API to bring up the same infrastructure. So if I want to scale up or scale out, if I want to virtualize, and if I want to use as much IT technology as possible, this one computer with this one NodeRed instance is really just part of a much bigger ecosystem. And that ecosystem consists of potentially multiple NodeReds running on each computer, multiple computers running that dynamically configured infrastructure. So I've got those computers. Now, at some point, I want to describe what I want to achieve in my facility, the workflow that I want to achieve, and the policy that I want to achieve that with. The vision, so this is an architecture, the vision of where we want to go. I want to be able to load that media workflow into a generic IT workflow engine and rules engine, maybe something from a company like MuleSoft. Use that engine to spin up dynamic software infrastructure, so cloud resources or private cloud resources, hybrid cloud resources, whether that be storage, network, or compute. Deploy the necessary workflows across the NodeRed instances. And I want to have a feedback loop. So I want to know when my computer is struggling, when it's running out of resources, when the streams are running too slow. So what we've done in our NodeRed instances is we've added both monitoring to the computer, how much RAM is being used, how much CPU load is being taken up. We've added to those pipelines that you saw, how fast is the media flowing down the pipe, and how long is it taking in each stage. For example, how long is each frame taking inside the FFmpeg transcoder? We put all of that information into a time series database. We use InfluxDB, but it could be Logstash, could be Kibana. And we can, in the vision of the architecture, the workflow engine can then be responsible to receiving that feedback and therefore reconfigure the infrastructure to make sure the critical workflow isn't impacted. We can use automated software deployment and DevOps techniques to deploy into this arena. And we can use NMOS-style registration and discovery So Streampunk wrote Ledger, which I think some people are using here, the NMOS registry discovery, to be able to have a view as to what our infrastructure configuration currently is. And obviously we need common timing across the piece. But the key thing, what we're trying to get to, is enable a world where the only thing that is really media specific is the modules, the software modules inside here, and obviously the cameras and the microphones as well. So, key takeaways from my presentation. The JTNM reference architecture was designed to be an enabler for a whole range of dynamic media workflows that this is an instance of, and the technology I'm showing here is also an instance of, that would allow us to go beyond SDI. For example, what if I wanted to spin up an infrastructure to do personalized TV for each of my customers? I've shown you a pattern which should enable us to do dynamic, software-only, stream-based infrastructure. And our proof of concept is demonstrating that this is feasible today. And we're hoping to have a demonstration, actual broadcast done out of this in Belfast by September. We are already, if we're all technologists, we're probably all playing with smart home technology at home, getting our light bulbs plumbed into our iPhones or our heating systems controlled remotely. So why not use the same technology for our media infrastructure? Can we ride that Internet of Things technology and the security patterns that it has and the user management patterns that it has for building our media infrastructure? We're software specialists, so we're trying to make sure we use very efficient use of the IT platform, which is the same platform that Google and Amazon and Microsoft have in their data centers. Making sure that we're cloud fit, we're scalable, secure, and we're sitting on IT tool sets wherever possible. We're giving away, as a company, a whole load of open source prototypes. We call them funnels for inputs, valves for transformations, spouts, outputs. It's a steampunk thing, you might gather. And we're trying to create an environment that gives a much more business agility, allowing us to trade latency and bandwidth where that's necessary. So not everything is live sports. There's a lot of uses of SDI which are not live. And also provide an environment in which we can glue RTP with HTTP, with MPEG transport streams, with files to build stream-based infrastructure. The next steps for our project are to add a whole load of additional devices. So we've been using Blackmagic, but we'd like to use Arjo, we'd like to use DECTech and so on. We're also working with uncompressed and compressed streams. So how can we basically transform these streams, compress them fast, but without cooking a chicken on the back of the server rack? And we're going to try and build a virtual vision mixer that works in this environment, with just a simple vision mixer. So we are Streampunk Media, a brand new company. You can find us at the Amwer Futures Park. I'm quite happy to try and do a demo depending on internet conditions in the hall at the time. Thank you very much.